launched in 1955, few could have imagined a future where the resulting technology would play such a critical role in everyday life for governments, businesses, and individual consumers like it does today. Satellites, rockets, and space stations have sparked tremendous advancements in everything from communication and navigation to remote sensing and intelligence gathering to cutting-edge scientific research. Over the last 20 years, the International Space Station has conducted research that has led to breakthroughs in drug development, 3D printing, and water purification systems. Satellites provide internet, TV, and radio around the world, feed our weather forecast and geophysics models, and help us navigate that world with GPS. They even yield precise timing for financial transactions. And telescopes like the Hubble and James Webb continue to help us unlock secrets of the universe and the origin of life. Satellites are smaller, more advanced, and cheaper than ever, enabling companies like SpaceX and Planet to launch mega constellations that act as distributed space systems, which can accomplish objectives otherwise impossible with a single spacecraft, like delivering internet to the most remote places on Earth, or providing high-resolution, complete images every 24 hours. Features like free fall in space eliminate complications from buoyancy and convection currents, and can improve product quality for alloys, optics, and semiconductor material. The vacuum of space provides a contaminant-free environment essential for manufacturing solar cells, integrated circuits, and pharmaceuticals. Future potential includes space mining for important minerals, space-based solar power that can beam energy down to Earth in the form of microwave transmissions, and optical communications advancements. Of course, the challenges of space technology are as big as the possibilities. Orbital debris from satellite collisions and increased space traffic could threaten access to near-Earth and outer space. The proliferation of space assets calls for new technologies, like on-orbit servicing, to increase autonomy, safety, and security. Anti-satellite weapons in the hands of rival nations or bad actors could threaten global communications and military operations. There is also much work to be done in ensuring cybersecurity for space systems, updating legal frameworks like the Outer Space Treaty, and regulating private space actors. Right now, space assets are not designated by the U.S. as critical infrastructure, but legislation has been proposed to change their designation. The U.S. has been at the forefront of the space race from the very beginning.
What is STEM? STEM is not just a subject at school. It's a way of thinking and doing, and an important skill set that could see your generation working together to solve some of the world's greatest challenges. STEM stands for science, technology, engineering, and mathematics. But it's not about being an expert in all of those things. Instead, it's about harnessing the essential, transferable skills behind them. Scientists know how to hypothesize, experiment, analyze, and evaluate what they discover. Technology can make our lives better. Designers of all sorts work together to make everyday tasks more effective and more fun. Engineers don't just wear hard hats. They are problem solvers that work on some of the world's biggest challenges, like creating bionic limbs for people with disabilities or exploring outer space. Mathematics teaches us how to quantify data and how physics rules the world around us. With mathematics, we can implement change and minimize error. You won't have to master all of these skills either. Teamwork is an essential STEM skill. Take the search for new energy sources, for example. Geologists and geophysicists search for gas deposits. Engineers help you design and run platforms and processing plants. Construction teams work to build essential infrastructure under the supervision of project managers, and environmental scientists work with everyone every step of the way. Playing to your strengths and working in a team will have you creating a greater impact than if you were working alone. It would cost the Australian economy $9.3 billion in lost productivity, profitability, and employee satisfaction. STEM skills are useful to almost every career. 75% of today's fastest growing careers require STEM skills, and 82% of today's employees say they value STEM skills even if they're not required for the job. STEM skills can even unlock your potential to earn a higher salary or become more employable. You don't have to earn a university degree in STEM to be successful either. There are plenty of courses to get you started in STEM. But we don't have enough STEM graduates to meet demand. Numbers show the demand for STEM careers has grown 79% since 1990, but enrolments in STEM degrees are at an all-time low compared to the last 20 years. And despite the job opportunities, just 16% of STEM professionals are women. STEM careers can start small, then change the world. Engaging in your high school STEM classes or learning to code could be your first step to delivering driverless vehicles to the roads. Starting a research project at home or entering a science competition could see you defeating cancer with a cure. And that's just the beginning. We don't yet know what kind of jobs will exist 10, 20, 30 years from now, but with STEM, you're prepared for anything. How will you shape the future with your STEM skills?